Hello again and welcome to this video on Day 0 configuration of the hub site using the APIC-EM IWAN app. In this video we'll pick back up where we left off after installing the IWAN app by getting our hub and transit sites configured. If you recall from the topology overview video, we have 4 ASR1Ks acting as border routers in our lab, 2 of which are behind a firewall. Now, I'll save those 2 for another video, but today we'll concern ourselves with the MPLS border routers since they're the easiest to demonstrate. And additionally, we'll light up the hub and transit master controllers. As a reminder, while we do our best to include as much relevant information as we can in videos such as this, make sure you reference the configuration guide for your version of APIC-EM to make sure there aren't any additional items you need to review. And with that, let's get started. As is the first step with most projects of this nature, we'll want to make sure our environment is good to go before we start blasting configuration to it. And as such, we've compiled a bit of a checklist for you to consider as you prepare. First, ensure that you have the correct licensing installed on your master controllers and border routers. For an ISR 4K, you'll want the application experience and security licenses. Likewise, for CSR1KVs, you'll just need the application experience license since it will include the necessary security feature set. And if, like us, you're running ASR1Ks, you'll want the Advanced Enterprise or Advanced IP Services software with or without the IPsec license, depending on your platform. Remember, if you purchase your routers using Cisco WAN Foundation, you're entitled to the necessary licensing you'll need for IWAN, but you'll still need to make sure that it's installed. Next, make sure that you've got the right iOS loaded. As of the time of this video, the minimum software release we recommend is 3.16.4b. Additionally, there's some basic configuration tasks you'll want to complete so that things go smoothly during provisioning. First, make sure you have your LAN and WAN IP addressing already squared away. The IWAN app will use these as seed values when you make your way through the provisioning process. You'll also want to make sure that a LAN routing protocol is configured so that the hub site subnets are properly redistributed into the WAN overlay network. This should only be done on the hub border routers, however. Do not configure a LAN routing protocol in the master controller since one will be provisioned for you by APIC-EM. For now, a static default route is perfectly fine. Configure a login that APIC-EM can use for provisioning purposes. If you're using AAA, make sure to set up a local instance of these credentials in the event that APIC-EM needs to log into the router and AAA is unreachable. APIC-EM queries the device for its capabilities using SNMP, so you'll want to make sure you've got a read-only string set up for it to use. SNMP v2 is the default with APIC-EM, but SNMP v3 is also supported. If you're going to use SNMP v3, make sure that you select CBC DES or CFB AES-128 as your privacy method. And since the CLI is used to provision these devices, we recommend that you configure additional VTY lines in the device so that APIC-EM can spin up several sessions to the device simultaneously. Lastly, here's a couple things you want to avoid as you prep your devices. First, don't use the phrase IWAN-EIGRP in EIGRP named mode when configuring your LAN routing. This name is reserved for the WAN overlay. And secondly, avoid using the 192.168.2.x address space. This space is used internally for asynchronous routing checks between border routers. Now that we know our environment is prepped and ready to go, let's head over to the controller. From the IWAN app main dashboard, start by clicking on the Configure Hub Site and Settings portion of the wheel. From there, you'll be prompted to create your first credential profile, which APIC-EM will use to log into your routers. Enter your router's login credentials and head back over to the IWAN app. Clicking on the Configure Hub Site and Settings button again should now bring up the provisioning wizard. You'll first be placed in the System tab where you'll configure global parameters of IWAN that get added to all routers in the domain. Since NetFlow is a chief component in providing flow visibility to tools like LiveAction or Prime, enter the IP address you'd like each router to export records to, along with the port that the collector is listening on. In our case, we'll be using LiveAction, which uses the default port of 2055. Depending on how you have APIC-EM deployed, select whether it's behind a NAT or proxy gateway. This setting ensures that services like APIC-EM's built-in certificate authority are referenced via the public NATed IP address as opposed to the private. For more information on deployment modes, see the Deployment Considerations video earlier in this series. A domain name is also required so that certificates can be properly generated. Note that if you already have one configured on the device, it's not going to be overwritten by this value. And as mentioned previously, APIC-EM will utilize SNMP to poll devices on their status and capability, so enter your read-only string here in the space provided. If you'd like, you can click on the Show More button to be presented with additional options to configure. And when you're satisfied, click the Save and Continue button. Next, we're presented with the Certified iOS Releases tab. In this optional step, you can choose what iOS you want pushed to each of your routers when they check in over Plug and Play for the first time. Note that images will only be pushed to Greenfield routers over Plug and Play. Brownfield image download is not supported. Bear in mind, however, that even a Brownfield router can be presented as Greenfield if configured to do so. More on that in subsequent videos. To provide an image for download, simply drag and drop it onto the window corresponding to your platform. Click Continue to move on. On the next screen, we're presented with the IP Address Pools tab. Since IWAN has various needs for IP addressing, things like the tunnel overlay IP addresses, loopbacks, LAN interface addresses, and so on, we need to provide a pool or pools for it to use. Pools are also used to auto-configure prefix lists within PFR. Start by entering the remote site count and service provider count. Here, it's best to enter the maximum amount of sites and service providers you see your organization growing to so that the tool can properly calculate an adequate subnet size. Once you have these values filled out, click the Check IP Range button. This should give you an idea of where to position your subnet mask. Now, if you're using version 1.4 of the IWAN app, your screen will look similar to mine. 1.5 changes things a bit, however, by splitting out the generic pool into separate overlay versus loopback pools. And additionally, version 1.5 allows you to choose which pools are applied to which overlays. Conceptually, the configuration is the same, however. Click on the Add Address Pools button. Since we're just concerned with getting the hubs provisioned, we'll add a generic pool. And as previously said, this pool will be carved up by the IWAN app to address the WAN overlay network and loopbacks where necessary. Additionally, you could also add a separate LAN Greenfield address pool. This would allow the IWAN app to assign a different pool of addresses to LAN interfaces as they're brought online, instead of pulling them from the generic pool. In cases where you have existing branches and you know that they won't be using Plug and Play, you can set up a LAN Brownfield pool. Now, contrary to its name, the LAN Brownfield pool is used to summarize the LAN address space for all of your Brownfield branches. No addresses will be assigned from this pool, rather, it's used to create a summary route that's pushed down to your IWAN branches. This is helpful most especially during a migration. As a final note on this screen, notice at the bottom that you can configure site-specific address pools. Now, as implied, this allows you to be more selective about which sites get which IP address space when they're brought online. Simply click on the Add Site Address Pool button, provide the serial number of the device corresponding to the site you wish to deploy to, provide a name, pool, and prefix, and you're all set. Click on the Save and Continue button to proceed. Our next tab is for service providers. Here, click the plus sign to indicate how many service providers you have in your environment. We'll start with our two MPLS providers. Provide a name and choose Private as the WAN type. In this screen, we're also presented with our service provider QoS models. Now, generally speaking, IWAN categorizes traffic into 12 classes on ingress into the border router. On egress, the border router will collapse these classes down to 8. Since service providers support a variety of QoS models, it's imperative that you know which model your SP supports. For example, if your SP supports a 4-class model, the IWAN border router will need to collapse the egress 8-class model further so that it conforms to what your service provider expects. Note that original DSCP values will not be overwritten. Rather, the 8 original classes of traffic are encapsulated into 4 aggregate classes where a new DSCP value is written to the tunnel header. Once the packet is de-encapsulated on the remote end, the original 8-class model will be revealed and treated appropriately. If necessary, click the green Profile button to copy one of the default classes and create your own. In our case, we need to increase the priority queue bandwidth to 20% to conform with SP1's policy. Once satisfied, click the Continue button. Finally, in our last tab, we'll get the IWAN app rolling with access information for the routers it needs to configure. We'll start by clicking on the External MC button since our lab has a separate master controller. From here, it's simply a matter of clicking on the green plus signs to provide APIC-EM with the necessary IP addressing and interface information to proceed. Follow along as I make the necessary edits. Be aware that this may take a few moments as each device is validated. Also, note that after we supply credentials and SNMP information once, It's pre-populated in subsequent devices. Once all devices are validated, set up each of your SPs by clicking on the green plus icon. Note the option here to use a loopback for the DMVPN tunnel. If you chose to deploy your border routers using the iBlock method, where your BR is behind an existing CPE, using a loopback to terminate the tunnel will ensure that any subsequent removal of the CPE goes smoothly, since no IP address changes will be required. Instead, you would just ensure that the loopback always remains reachable regardless of your topology. Additionally, had this been an internet-facing border router, you'd also have the option of configuring a NAT IP. This option instructs your branch routers that the hub router exists behind a NAT device, and as such, the IP you input here will be the IP address that your branch routers direct tunnel traffic towards. Next, we need to set up routing for each of the DCs. In the upper left corner of each DC, click the green plus sign. In the top portion of the screen, select which routing protocol will be used on the LAN side of the master controller. Here, we're using EIGRP with an autonomous system number of 100, but OSPF and BGP are also valid choices. The IWAN app will populate the lower half of this screen with any prefixes it found in the BR routing tables. These will be used to configure DC prefixes for use with PFR. Feel free to summarize this list, but make sure that you have a corresponding route in your routing table that covers your summarized prefix. For instance, our DC prefix is 10.50.100.0/24. In order for PFR to control this traffic, a parent route must exist in the router's routing table that includes this subnet, such as 10.0.0.0/8 or 10.50.0.0/16. When you've finished, click Save and Continue. On our final screen, we'll review the configuration that APIC-EM will be provisioning to our hub and transit sites. You have the option of applying this configuration now or scheduling for the future. We'll go ahead and apply it now. And after a few minutes, we can see that APIC-EM is finished deploying our hub and transit sites. From here, feel free to poke around on the command line of these devices to see what APIC-EM did. And as always, if you have any questions about what you've seen today or have a suggestion for a use case you'd like to see, feel free to reach out to us at iwanapp-pm@cisco.com. Thanks for watching, and I'll see you on the next video.